Ever wondered why a right-angled triangle holds a special secret within its three sides? Today, we're diving into the world of geometry to illuminate a principle that's as old as the ancient Greeks, yet as relevant as the smartphone in your pocket: the Pythagorean theorem. Now let's talk about the right-angled triangle. Picture a triangle with one angle measuring exactly 90 degrees. It's this particular type of triangle that holds the key to our mystery. The Pythagorean theorem, named after the Greek mathematician Pythagoras, is a fundamental cornerstone of geometry. It's a simple yet profound equation that relates the lengths of the sides of a right-angled triangle. This theorem has wide applications in our daily life, from architecture to navigation, even in the realms of space exploration. So, are you ready to delve into the depths of this geometrical gem? Stay tuned as we unravel the secret hidden within the right-angled triangle. Welcome back. Are you ready to discover the secret of the right-angled triangle? Today we're diving into the heart of the Pythagorean theorem, a fundamental principle of geometry and a cornerstone of mathematics. Named after the ancient Greek philosopher and mathematician Pythagoras, this theorem is a simple yet powerful tool that has been used for over 2,000 years. Here's the theorem in its most basic form. In any right-angled triangle, the square of the length of the hypotenuse, which is the longest side of the triangle and opposite the right angle, is equal to the sum of the squares of the lengths of the other two sides. In other words, if we label the hypotenuse as C, and the other two sides as A and B, the Pythagorean theorem can be written as a squared plus B squared equals C squared. But what does this actually mean? Let's break it down further. Imagine a right-angled triangle. One side is adjacent to the right angle and we'll call it A. The other side, opposite the right angle, is B. The longest side, the hypotenuse, is C. Now if you were to create a square with each of these sides as the length of the square, the combined area of squares A and B would be equivalent to the area of square C. For example, let's say side A is 3 units long and B is 4 units long. The hypotenuse, C, would then be 5 units long. This is because 3 squared or 9 plus 4 squared or 16 equals 5 squared or 25. 9 plus 16 equals 25, proving the theorem. Seems magical, doesn't it? But it's not magic, it's mathematics. This simple equation is a bedrock principle that's used in countless fields, from architecture to astronomy, making it one of the most influential and enduring theorems in history. Now you've got it. The hypotenuse's square in a right-angled triangle equals the sum of the squares of the other two sides. But where does this theorem come into play in the real world? Well, you'd be surprised to know that the Pythagorean theorem is not just confined to the realm of triangles and geometry. It's a practical tool that finds its applications in a variety of fields. Take architecture, for example. Architects use the Pythagorean theorem to calculate distances and angles, ensuring that buildings are structurally balanced. It's an essential part of designing both simple and complex architectural structures. In the field of navigation, it's used to determine the shortest distance between 2 points, saving time and resources. In computer graphics, the theorem helps in rendering 3D images, calculating pixel locations, and even in making video games more realistic. It's truly fascinating how a simple mathematical concept can play such a crucial role in our daily lives. So the next time you see a perfectly balanced building, navigate your way through the city, or play a video game, remember the Pythagorean theorem. As you can see, Pythagoras theorem is not just a mathematical concept, but a practical tool used in various fields. So, why is Pythagoras theorem so important, you may ask? Well, it's a cornerstone of geometry, and it's been guiding architects, engineers, and even astronauts for centuries. It's all about the relationship between the sides of a right-angled triangle. Remember, the theorem states that the square of the hypotenuse equals the sum of the squares of the other two sides. It's a simple formula, but it's incredibly versatile. From helping architects design buildings to enabling GPS systems to pinpoint your location, the theorem has many real-life applications. Moreover, it's not just about practicality. It's also about the sheer beauty of mathematics. The Pythagorean theorem shows us how numbers and shapes can intertwine in the most elegant ways. And it's a testament to the human mind's ability to decipher the patterns and principles that govern our universe. And that, dear friends, is the beautiful secret of the right-angled triangle, a gift from the ancient mathematician Pythagoras.